Hi. So in the last video, we saw how the ON squared solution had a time limit exceeded on LeetCode, which meant we needed to optimize even more. So in this video, we're going to be discussing a surprisingly very easy solution. Its implementation is actually just a couple of lines, and it's even much better than the ON squared solution. So if you remember, the ON squared was quite a number of lines, maybe 20 or 30 lines. But as you'll see in a few minutes, the ON log n solution is very optimized, and I think some of you, or most of you, might have, not most of you, but some of you might have gotten the idea for it, or fiddled around with it while thinking about the problem. So yeah, let's just jump into what the idea is. So let's again get the idea for anagram. Okay, so our running example is anagram and nagaram. Okay. Now, one possible idea, if the ON log n hasn't given you the idea for the solution yet, usually an ON log n involves some sort of sorting, right? So, what happens if we sort S in the alphabetical order? So, if I sort this, I would get, well, A comes before, then A, then let's see, A, B, C, D, E, F, G. So G comes, H, I, J, K, L, M, N, O. So N is here, and then all the way to Q, L. Oh, whoops. So L, M. We have an M here, and then an N here, and then we have an R. So after sorting S, we get A, A, G, M, N, R. What about T? If we also sort T, then we get A, then G, then M, then N, then R. So do you see any similarities between the two? And of course you do. They're exactly the same. So the whole idea, or this very simple idea, is it's literally like a couple of lines. So you just check if the length of S is not equal to the length of T, then you return false. Okay? Then what you do is you say sort S alphabetically, and then sort T again alphabetically, and then return S equal to T. So if S is equal to T, return true, else return false. And that's basically it. That's the entire algorithm, literally 4 lines of code. And the idea is really, not super intuitive, but you might have kind of guessed it a bit. And the idea is we have the same letters, right? In both of them. So why not just order the whole thing, right? Order the entire array S and T into an order which they two might agree on, and then check if they're exactly the same. So instead of trying to match each letter to the other one, why not just first sort it and then see, okay, there's an A here that I can match, there's an A here that I can match, there's an A here that I can match, a G here, an M here, an N here, and then an R here. So we're still doing the matching, but we're doing it in a smarter way. Instead of just like here's an A, let me just go all the way and check if there's any A here. And then here's an A, let me go and search over all A's in that range, and so on. So in this case, it's super intuitive. It's just you basically sort this array, sort S, sort T, and check if they're equal. If they're equal, then there is indeed a matching between them. If they're not equal, then that means that they're not. There's no matching that would match the two of them. And I'll actually leave the proving the statement as an exercise. It's not really a statement. It's sort of a bit intuitive. But you can actually prove it rigorously if you want to do like some sets and say, okay, let S be the set of letters in the word S, and T be the letters in T, and then sort of try to make an ordering statements on S and T, and try to derive a contradiction in case you basically want to show that the letters here, if the sorted S is equal to sorted T, then S is an anagram of T. So hopefully you can do that as an exercise. It's really mathematical, not very CS-y, but yeah, it's just an interesting exercise in case you're interested. So yeah, in the next video we're going to be doing the implementation of it, which shouldn't take hopefully too long. So yeah, in the next video we'll see how to do it. So until then, happy coding.